Hi and welcome to John's Maths Book. In this video, we'll be exploring another key concept in mathematics. If you find this tutorial helpful, then please show your support by subscribing, liking, and leaving a comment. Your positive engagement helps me create more content and allows me to bring you more valuable maths lessons. Without further ado, let's go over to the whiteboard. Let's talk about integrals of the form f prime of x divided by f of x dx. So in simple terms, when we have an integral which is a quotient and the numerator is the derivative of the denominator, we see that in this situation, the integral evaluates to the natural log of the absolute value of f of x plus a constant of integration. Let's see why and take a look at a couple of examples. So let's say we have this integral, which I've circled, where f is some function of x. How would we go about integrating this? Well, let's begin by trying a substitution. So we'll let u equal f of x. It follows that du by dx is equal to the derivative of f of x, or f prime of x. And therefore du is equal to the derivative of f of x dx. So now, if we make our substitution for f of x, we have the integral of 1 over u du. And this evaluates to the natural log of the absolute value of u. And if you'd like to see why this is the case, please check out this video. I'll post a link to it in the description of this video. And substituting back in for u, we have the natural log of the absolute value of f of x plus a constant of integration. So now let's look at some examples of this. So in the first example, we have the integral of 2x divided by x squared plus 3 dx. In this case, f of x, which is the denominator, is equal to x squared plus 3. And f prime of x, which is the derivative of f of x, is equal to 2x, which is the numerator. So now if we let u equal f of x, so u equals x squared plus 3, du by dx is equal to 2x, and therefore du is equal to 2x dx. If we now make our substitution, we have the integral of 1 over u du, and this evaluates to the natural log of the absolute value of u. And substituting back in for u gives us our final answer of the natural log of the absolute value of x squared plus 3 plus a constant of integration, which we'll call c. So in our second example, we have the integral of cos x divided by sin x dx. So in this case, f of x, the denominator, is equal to sin x, and f prime of x, so the derivative of sin x, is equal to cos x, which is the numerator. So now if we let u equal f of x, so the denominator, u is equal to sin x. The derivative of u with respect to x, so the derivative of sin x with respect to x, is cos x. It therefore follows that du is equal to cos x dx. And if we make our substitution for f of x, which in this case is sin x, we have the integral of 1 over u du. And this, as we know, evaluates to the natural log of the absolute value of u. And substituting back in for u, we get our final answer of the natural log of the absolute value of sin x plus a constant of integration.